upon the same topic of component testing. In particularly, we will look into end-to-end testing. Some tips on how to do manual testing for your semester project. And in the end, we will spend most of the time around stress testing and load testing for your application. And then we will talk about the mock exam. So I have the mock exam ready. So if you want to take it here in the class, you can take it here, or if you want to take it at home, it's also fine. We'll discuss about that. And then we'll talk about the final. If you have any question about the final exam, we'll discuss that. A quick recap of what we discussed in the last lecture. We discussed about the observability and monitoring in the microservices and why it is important as your application is growing, monitoring and observability becomes really, really crucial. So we saw how to set the Prometheus and Grafana sort of dashboard to do the monitoring at one place in a more effective way. So you can pinpoint the bugs and also plan out your other things like scalability and all that stuff. Then we also saw the software pyramid testing. We saw about unit testing, which most of you are familiar with, but we discussed about what are some of the best practices when we do the unit testing. Then we touched upon the component testing, why component testing is important and how it is different from the unit testing. And then in the end we did discuss about the integration testing as to when to go for integration testing and what sort of components they make sense more to the integration testing. And we also discussed about the tools to mock, when you do the integration testing and component testing, when to mock and when to use the production-like environment for the testing. Any questions, thoughts, comments before we jump into today's class on what we discussed last time? Alright. Then, with that background, let's quickly jump to end-to-end testing. I don't have much slides today. We spend more time on doing hands-on performance testing. Okay. There's a typo here. So it's end-to-end testing. So we saw the pyramid, right? So this is, as we discussed, as you go from the bottom to top, the cost of software testing increases quite significantly. So that's why it is super important to have a good unit test. Okay, just a quick question: why do we need other kind of tests if we can do 80 or 90% or 95% of error? If we can catch 95% of error in, let's say, unit testing, why do we need other sort of testing? What is the thought process behind? Why do we need other kind of testing?
Because you need the testing because of unit testing is very specifically targeting one thing, but it might not work in the context of a lot of other things like user behavior.
Yeah.
So
for example, then if you say you do the integration testing, right? Then why do we need end-to-end testing? Right? Okay.
If you do the integration testing.
Yeah. If you do, let's say, integration testing, why do we need to move up in the ladder? Like, why do we need to do now the end-to-end testing as well?
Because I feel like that's one step longer in the broader perspective that integration testing is. Intent is also it's all about user experience.
So you need to. So there could be some errors that you may not catch up in at this stage. So that's why you need to go up higher in escalation ladder. And the idea is that you do as much as you can do in these lower stage, so your cost of testing is quite longer. So, and that's the whole idea that like more you do the testing or thorough testing in the bottom, you spend less resources and time on doing the up. But the other the stack is equally important because there would be some errors that you cannot touch and cannot find in the lower stages. For example, if you do, let's say, integration testing, you test a couple of components, but then you need to move to the end-to-end testing where you sort of verify the full user flow from input to output and how this so for example in the integration testing you are testing only, let's say, this this part, right? And now in the full end-to-end testing, we have to test even the front end as well, the API controllers and everything we need to test with the end-to-end testing. And also need to add the user flow. So the purpose is to validate the complete functionality of the application and all the subsystems. So in the integration testing, we were just testing a subsystem within the system, and then in the integration testing, we have to integrate everything and test together. Yeah. So as I said, the error at the escalation level is that there would be tests, would be the bugs that you cannot catch in the lower stages, and that's why you need to move to this end-to-end testing to catch those bugs. Yeah. Also, in end-to-end testing is also clear, we're very much close to user behavior just before the manual testing. So this is very close to how the user would. But this part you still do automatic. You still automate this part of the end-to-end testing. Yes. So when would you go with the end-to-end testing? So before every major release, you do the end-to-end testing. And when it is still automated, so all the steps that you have in the end-to-end testing are still automated. Yeah. During CI/CD pipeline to prevent regression, so if you have any error, you don't want to progress them to further in the production. And also, this is the most important part, that you do the end-to-end testing of the most critical resources or paths or functionality in your application. That's where the end-to-end testing becomes really, really critical to pay special attention to. And you do this end-to-end testing very much close to the production environment. We saw that in unit testing, we heavily emphasized on mocking everything. Integration testing, we said go close to the production, but still mock at the container level, which is very close to the production environment. But in the end-to-end testing, you have to test with the real production environment. I mean, replica of production environment. Alright, so basically key takeaway is just before the release, and also when you are doing the CI/CD, so you should check, do the integration testing along with the CI/CD, and also check the most critical parts that your application has before every major release. That sort of things that you should build the automation for doing the end-to-end testing. Let's look into some of the pros and cons. Yes, the pro is that, as we discussed, it stimulates real user behavior close to manual testing, right? Validates the entire stack. That's also a very the good feature that you miss out some of the issues in the previous stack of testing. And also the integration bugs are also very difficult. I mean, to catch without end-to-end testing. And you straight away go to manual testing. That's even more costly. So that's why you want to catch them here. And the cons is that slower than unit testing and integration testing, as it's a huge sort of setup that you need to do and run. Each test would take a while to run. So it's more costly. You need to set up a parallel production, the parallel environment close to your production environment. Yeah, maintenance and setup is a big task in the end-to-end testing. Okay, so there are some of the popular tools that you could use employ to do the end-to-end testing, and that's still the automated way. The Selenium is one of the popular tools that industry uses, but you can pick and choose others as well to do the end-to-end testing. So this is sort of mocking user behavior with the Selenium test suite. We're not going to touch upon this because this is a whole topic in itself to set it up. Each of these testing sort of steps that we discussed, it's a huge sort of effort or like a learning curve to each of these tools. So this is again getting the tool specific. Depending on the application that you are building, you can pick and choose which tool to use and also which functionality to do the integration testing. You don't have to do everything. Don't have to do the integration testing of all the functionality. Just do the integration testing of your most critical functionalities and flows. Yeah, I mean, even for mobile applications, you would have different test suites that using which you could do the end-to-end testing. We saw how Mockito helps you do the integration testing, but for end-to-end testing, you would use any of these tools. And Selenium is quite one of the popular tools that the industry is using. Okay, what are some of the rules that you should keep in mind when you are doing integration testing? So basically, you have to have clear defined rules. Also, prioritize which path, as we already discussed, that you want to do. and set it up as realistic as possible using the mock, the realistic test data. And yeah, maintain test environment. So that's most important when you're doing the end-to-end testing. The environment has to be maintained and very, very close to the actual production environment. So that's sort of things that you should keep. Don't test in your development environment and then say, hey, everything works, but then in the production you face the issue. So always have a separate sort of test environment for when you're doing the end-to-end testing. Okay. Then the next thing in the escalation ladder is the manual testing. Why do we still now move to the manual testing? Okay, we did all these different types of testing. Now, then what is the need of manual testing? Any thoughts, questions? As we discussed, the cost is really high because you have to have a real tester sitting on the desk and doing all the tests manually. What is the need of manual testing? I mean, what is that you are trying to catch in manual testing? Yes?
The edge cases that were forgotten in the other testing?
Yes, but the counter question to that is, why can't you automate that as well? Can you automate that as well? Like, and just get rid of the manual testing altogether? Yes?
With the fuzzing?
What?
With the fuzzing.
Fuzzing? Like explain how?
If I there are tools to try different outputs, like random outputs in the product.
Yeah, but my question is why can't you automate that? Like why manual testing is still sort of is?
This user behavior at the end of the day is unexpected, so as much as you want to automate something, you can really automate the unexpected.
Yes. So in the manual testing, you want to go close to the user behavior as possible, and that's very difficult to predict and automate because users come in so many different varieties, and you have to keep that sort of thing in mind that the user experience you cannot sort of automate. Experience is something that you still need to have a manual testing. I mean, your APIs work really well, your integration works really well, but in the end, if that kills the user experience, then everything is useless, right? So the user experience part you cannot automate, and that part you have to do, for that part you have to do the manual testing. And also, as you mentioned, edge cases are still very difficult to think through and do the automation, and it's like more effort in doing that, like figuring out the edge cases and then automating those edge cases. It's like the effort or the time that you spend is equivalent to manual testing, and that's how you would still go with the manual testing. So let's look at the pros and cons, and when you're deciding how much to do the manual testing and where to put like more effort, whether you should automate it or you should still do the manual testing. So you should weigh against that. So yes, advantage is that you get human insights and intuitions. So it's very difficult to automate the intuitions, and that's the most critical part, because when you look at an application, it's like you can get the intuition of what would allow a user at, let's say, like at different stages. So these intuitions are very hard to automate, and that's why you would still want to do the manual testing. And yes, there's a lot of flexibility with the testing. And also you can just straight away start with the manual testing. Let's say the initial cost of manual testing is low, but as the application grows, and you have the cycles and repeatability, and that's where the cost would add up. But initially, like, you don't have to set up a parallel production environment, and like that's a whole DevOps setup you don't need to do. Like, you can just do the manual testing in the starting, and the cost is low. Even though we said that in the escalation ladder the cost is really high for the manual testing, but initial cost could be really low. And also the feedback loop is also very instant. And that's most important, like the UI aspect and the visual testing and all of that part becomes really handy with the manual testing that you cannot automate. Yes. What are some of the disadvantages? Of course, the cost is really one of the factor that really affects the manual testing. So scalability is also an issue as application grow, and each release you don't want to do the manual testing entirely. Yes, repetitive manual testing is, imagine before every release you have testers doing manual testing. That's sort of no-go zone, and that's also not cost-effective for real production systems. Yeah, and you cannot integrate it with the CI/CD. You cannot automate that sort of stuff. Also, that's one of the things that software, like even the previous test that we were seeing, that you can reproduce. You run on your machine, I run on my machine, I will get exactly the same error. But manual testing is hard to replicate. I mean, you can see that when people report issues on GitHub, they report in so many different ways and so many so that's also one of the challenge with the manual testing is the reportability aspect is and reproducibility of a bug is very difficult if you do the manual testing. Yes, you cannot cover everything. That's why that's also the limitation that ties up to the scalability aspect to this. And most important is the cost. That's where it boils down to, and time consuming is slow. It can slow your release and that you want to automate. Okay, so when to use manual testing? So what are the scenarios that you think are good for manual testing? What are some of the scenarios that you can think of where you think, yes, I think the manual testing makes most sense? Any thoughts? Yes?
Maybe small application that works there anyways.
Small application, but still it is good to do the other test suites as well, like even for small application, because even the application is small, but you can expect the repeatability aspect.
Sorry?
Even if the application is small, but you would expect that you would have a cycle of release, changes, even in small applications as well, right? So that, I mean, of course the scale is less, and that still makes sense, but like the repeatability aspect you cannot escape even in the small application. You would have the many iterations at least.
When there's hardware involved as well?
When?
When there's hardware involved, like you need to, I don't know, there's a probing machine or something. Stepwise.
Yes, so of course for the hardware sort of things, it's very difficult to automate that as well. So yeah, in that setting, we would definitely go with the manual testing as well. But in broader sort of things that we are discussing, leave aside the hardware part, that's becomes much more obvious that in the hardware you would need this kind of interventions. But let's say in the software space, that for example, instance of project you're doing, like when would you think the when is the best? What is the best use or utility of manual testing? Of course, we did discuss about the UX user experience and the visual aspect, validating the visual aspect as well. That's where you would choose. You have no option but to do the manual testing. Right? Other could be if you're doing the rapid prototyping, the early prototypes, you don't want to spend enough time in setting up the test suites, and you're just iterating really quickly, iterating on the. Have not reached to the stage where you just need to test everything. It's just in the early prototyping stage, you still choose to do the manual testing as compared to. Yes.
No, it's just well, you kind of answered it now. I was just wondering what, like, when you say manual testing, are you talking about when you're doing manual testing of, the idea phase, like ideation, or is it more manual testing for when you're trying to figure out if this stuff is working as intended?
So it's I mean, even in the ideation, when you're doing the user-centered design, there also you do the manual testing of a prototype that you have. You click through and you walk through, like that's also in the design phase as well. You typically do the manual testing. I mean, you walk through that's sort of manual, and then you're testing whether the design works or not. But this is typically about the system, like the coding, after the coding that you build the system, right? And that's what this manual testing is about. Like, of course, in the design phase, when you're designing an application, when you're doing the user-centered design, that itself has its own test. Like how do you test the user, the prototype itself? That's a different sort of tools and things that we use there. But of course, there also manual testing is equally applicable. But this is more about you have the code, you written some piece of code, you have a look and feel of your application, and then you are like trying to do the manual testing. So this is in the post development phase. Yeah. Yes. Also, especially when you're doing exploratory and ad hoc or usability tests. So that's where if you're doing usability test, manual testing is a must. You cannot avoid this. Right? So in case the test scenarios are complex and require human judgment and empathy, that's where it goes. So imagine you're let's say doing the testing for a complex banking application, that has so many aspects that needs to have human intuitions and things like to judge whether this is going as per intended. Because as we discussed, if you try to automate the edge cases, that itself becomes a bigger challenge than actually doing the manual testing. So that's where you say, okay, yeah, these are the kind of features that make sense to spend more time in the manual testing. Yeah. Especially judgment and empathy, because that is very hard to crack and very hard to automate. So when you're doing the manual testing, so you basically how do you go about? Okay, in your current project, how do you go about the manual testing? What do you do? What is the structure that you follow when you're doing the manual testing? Or do you plan to do the manual testing in your semester project? My advice is that you at least do 3 or 4 tools, like manual testing, unit testing, anyhow you are doing. You should definitely have the test coverage in your report and also in your presentation. That's really important because the examiners are looking. And then you also have the integration testing. Do some component testing, at least for the critical components that you have. Do the component testing. Do 1 or 2 integration testing, so that you show that you're familiar with the tools and how to do that properly and validate that. And also at least have a couple of manual testing as well. When you say I want to do, when you report, like in the report you can say, oh, I sit in my computer, I just checked everything, I did the manual testing. So that's the thing I see in most of the reports. Students say, hey, you did report on the testing, but all they do is say a paragraph, we did the manual testing or application. That's all they have. Like that's all they put in the report. We did the manual testing of our application. How did you do that? Like what are the sort of procedural things that you set out to do? So typically, for manual testing, you would have a document like this, where you have defined the test cases that you want to do the manual testing. What is, let's say, expected results for that manual testing, and what do you find, and like what is the status. So you prepare a manual test document. That's really important, and that you can just simply put in your application. At least prepare 1 or 2 manual test document that you say, okay, this, and you kind of put this against the use cases diagram or things that you have built. So in the end, examiners many times they ask, okay, how do you know your system works, right? What is, like, how do you say that your system works or fulfills what you intend to build? Then you say, okay, this is my manual testing. This is I benchmark against the use cases that I have. These are the use cases, and then say, okay, I fulfilled all my check marks. Like in the manual testing, I can see that I fulfilled all the requirements that I had, that I listed for my system. So then in that and you can use this as to say that yes, my system works, or whatever I intend to build, I built this, right? So prepare at least manual test document, if not like for entire, but at least 1 or 2 manual testing documents that you must have in your semester project report. That's really important. And don't just write 1 paragraph saying that we did the manual testing. That is really bad. And then I have seen that in the last year reports, even the students, they thought that they have said everything about, but that's, the testing is in your head. You have to document it as well, and that's proper way of documenting is try to prepare this manual test document and then benchmark against this, and at least have 1 or 2 in your semester project report as well. That's really important. So basically, and also imagine if you report this, right? So that itself becomes a big thing, right? If you are in an enterprise level, like you are part of a big organization, the testing team is different, the product, like the development team is different, the UI. So how do you communicate? So basically, this manual testing document could be a blueprint that everybody sort of agrees, and then when you say test case one, so and this is how you would use them also report what works, what doesn't work. So this is really, really important. Please at least do a couple of manual testing as well. Any questions, thoughts, comments? Have you been doing the manual testing in your previous projects, and how did you report them, for example? What did you use to report? How were you reporting your manual testing?
The way we did it was we kind of did the same as you have put up here. We just did it more like a page-to-page thing, so it would be like one page for one. We would just call it a user test, which would be conducted either by a test person that we found, described also in the report, or by the programmers themselves.
Did you prepare the test, the manual test document?
Beforehand, yes, like a step, like prerequisites, and then the steps, and then the expected results, and then actual results.
Yeah, and that's what you use to report in reports. Yeah, please do that. That's the most standard way, and that's how the examiners would expect you to do this the testing in a proper way, and not just saying we did you. Because that's one of the. Also try to do testing, and if you can, let's say there is a limit, I think 40 pages, right, for the report. That's what I'm going to put that template as well, maybe this week. But there is a limit for 40 pages, and if you have done more tests, please put them the results and everything in the appendix, and just refer it. But more you do, better it looks on when the examiner reads your report. Especially the old ones that you get for the exam, they are really very fond of test cases, and they're very much looking for this. If you don't have that, they'll start your reports from 7 or I mean 10 is, you forget. If you don't have good test cases, forget 10 or 12. They straight away jump to. That's what I have observed in the behavior, that they very much look for the test, and that's why I keep emphasizing that please do the test properly in for your thesis.
This might be more related to the actual exam report and stuff.
Yeah.
But would you recommend us putting at least one of them inside the report itself and then the rest in the context, or put everything in the context? Because we had the issue that we put everything in the context and they weren't really happy with that, because then we just make references and technically you're not supposed to force people to read it.
Yes, but see how it makes sense. Maybe just one. I think one in the report, one in the report, and then the rest in the. And if they say if they're not happy, then you can give the justification as well. Like we give the 10 cases, 10. Let's say we do the integration testing of 10 different components, and then you just cannot put everything. Then the 40 pages will be bloated. But at least put one. I think that's a good to have that visual sort of or aspect to that. Yeah. Yes, that's a good strategy. I mean, if you just put everything in the appendix, that also doesn't look nice. But at least put one or two. Again, everybody writes differently. Somebody can fit 40 pages and they can put more. That's again very individual, the project specific thing. But try to put as much as you can in the area which is like out of the limit. Then you can just try to put them. All right. Any other thoughts, questions? No. Okay. Then let's jump to performance. Have you been doing the performance testing, by the way, for your applications? Any sorts of performance testing that you did in the previous projects that you had? All right. So I think we'll spend most of the time for this class on performance testing, and this is really interesting and fascinating as well. Once you get into that territory, it's like that's where your real architect hat really comes into play, and how do you make your application. You start thinking about all the edge cases and the coding flows, or like sort of the for loops that you put, like all of that becomes really like the science student comes in front of you. Like you have to like sort of optimize your code. That's where once you start doing that and looking at this performance testing, that's where you become more sharper in your code actually. Like you can see through your code like what part is the bottleneck, which part do I need to refactor, that things actually shines through once you like sort of master the performance testing. So performance testing is primarily about the non-functional requirement side of things. So That's what you focus with the performance testing. I mean, this could be required. Speed could be requirement as well, but primarily it's more on the non-functional requirement side of things, where you want to do the performance testing. It could be, let's say, peak load on your system that you put, how many users, concurrent users that your system can handle, or like what's the bottleneck that you want to test your system against in a real world scenario. What can go wrong? Let's say if you build an app or a system and you just deploy it. If you don't do the performance testing, what would go wrong is if it is slow, it kills the user experience. And the cost is huge. If you are a brand, if you're starting something new, you want to build a brand, and the user experience is really bad just because of the performance. It's slow and the user is getting frustrated. So the cost is really high. That's why in real applications it becomes really important that you do the performance testing before you do the release. Right? Also, it could also violate, let's say you have terms of you are expecting payments from somebody and then you delivering a system and then it doesn't work. So it's also a violation of terms of service and all. So it has huge implications for your application success. And that's why the performance testings are in a production systems are really important that you should pay attention. What do you test? First is the thing that you test is response time. How fast is it? So currently what we do, we just rely on a visual sense. Okay, we just load a website and see how good that feels. Right? If you have to wait for a particular page forever, like that kills the user experience. And the typically that you do is for each assets that your application has, you want to test the response time of each one. If you have API call, or if you have page load, if you have anything in your applications, you want to test the response time for each of them, and you want to measure the responsiveness. Then you can decide, for example, in many of the websites, what they do is the static part they cache it on the front end servers part, and also they do the caching on the, let's say, some other like things like Cloudflare or things that they use. So basically the static part they do the heavy caching, and that's where they sort of improve the response time. If the web page is really big and they still want to have good response time, you want to do the heavy caching, and that you can do once you know, okay, what is the response time that I'm expecting the user to have, like sort of that doesn't kill my user experience. So response time is really important, either be it API asset or like any other front end assets that you have. And also throughput is like number of transactions the system can handle per second, like you said, the user load, how many concurrent sort of things that it can handle. And that's where you want to do the performance testing. As the scalability, if you want to have test the scalability of the system, that's where you would handle the like how would the system scale with the increased load, and that you can do the systematic testing and know where it fails. That's really important, and it's not a guesswork. Like let's say you build an application, 10,000 users, you will know where it will fail. Like that you build the predictability of your system failure with the performance testing. Also the stability. So if you want to have all of these, like if you want to know upfront about the system, where is the breaking point, what's the response time and all of that, so that you need to have the performance testing in place. And how do we do that? We will, of course, this becomes really important if you are, let's say, doing the dynamic scaling of your system. You need to monitor the scale, the monitoring, CPU time, disk management. We saw that like in the microservices, how do we do that? So in the last lecture, we saw the observability of microservices, monitoring. So from that, we do get the memory and CPU and disk uses, all of that. So typically what you do is that you do the performance testing and you look at your tools that we saw in last lecture, the observability and monitoring. You can also see the spike, or we will see in today's class as well, as to how at one hand the performance test is running, and other hand you have this monitoring, CPU monitoring and network monitoring is going on, and then how do you correlate that to know the peak point for your system. We will also see that in today's example that we do. So yeah, these are the points, responsiveness, throughput, scalability and stability and resource uses that you want to do performance testing. Does this make sense? Like, is it like the point clear about why would you go for the performance? It becomes really important because for semester project it may not be the thing, but for the real world systems it is the must requirement, and it's a non-functional requirement, but without this system would fail for sure. And that's why the non-functional are sometimes more important than the functional ones, because if you don't have non-functional in place, then yeah. So okay, in the performance testing there are tons of different types of things that we can test, and but primarily in today's class or like the scope of this we would do the load testing and stress testing. So how is the load testing different from the stress testing? That's right. How or are the two same? Yes. Okay, how do you do the, let's say, load testing? How would, let's say, you are building a semester project, I want to test, I want to do the load testing. How would you go about? Let's say pick maybe, let's pick your project. How would you go about stress? Let's say first do the load testing. What is the load testing for your system?
Since we're having the OPD vertex,
Mm-hmm.
load testing in my mind, you control the number, like the quantity, and the stress testing you go for peak. So in the case of, for example, email sending, if you want to control how many emails you want to see, like in a certain time, you would go for load testing. Like you measure, like let's say 500 emails or 1,000 emails that you send. Like, let's see how the CPU usage handles that one. And then for stress testing, in the LLM part, how much, let's say how much gibberish it says, so that you can filter it beforehand. So you're testing at that moment, like the peak of your LLM. You don't know the capacity of it, so that's why you go with stress testing. You see how much you can put it forward.
Yeah, that definitely makes. So the load testing and stress testing, they have their distinct utility. One, you just try to get the peak of when is the sort of when is the breaking point for the system. So they do have the different feasibility. Like the focus is basically different. So for example, in the load test, the focus is the response time, throughput, user system behavior under typical conditions, and then in the stress testing, you want to test the stability and recovery, or let's say if it breaks down, how does it like recover? The system comes into again. You have to build through that. If it fails, how does it recover? Like that's also, if everything crashes, how do you have the systems in place that it recovers, and how do you test it? Like let's say if you don't do the stress testing, you build a system and it crashes. You have to crash it and then say, okay, this crashes, and then I test my recoverability. You cannot just deploy, and when it crashes there in the deployment, and then you're going to do the stress testing of the system, because then if the cost is huge, because the system is down for, let's say, for some time, and then that itself is a cost to the company, right? So you want to stress test them beforehand and know the peak, and when they will fail. So all of this, the stability and recovery is also important, because once you, let's say, you build a Docker, when you build the Docker, let's say Docker crashes, or your Docker daemon crashes, then how do you automate it that it comes back again? Right? So all of these things that you can do, and then test against as to how is the response time. So for today's class, we will just focus on the load and stress test primarily. But just know that the focus that you do with each, although they look similar, right? Load and stress, like intuitively, like okay, they are kind of testing similar things, but just know that the focus area that you do in each of them is slightly different. Okay, yeah, there are a bunch of other tests that in the real system that you also do, but for today's class, this was for, because just to learn about doing one kind of test itself is a big learning curve to that. If you're interested, you can go and explore on your own later on. And there are some popular tools. Have you been using any of these tools in the past to do some kind of load testing, stress testing? No? Yes?
E6.
Easy? Okay. You have done some testing, load testing with that? Okay, that's good. So yeah, so there are a bunch of popular tools depending on what your tech stack is. In today's class, we going to learn about JMeter. This is again a really nice tool for doing the performance testing. But the principle for most of them remains the same. It's just a tool. Okay, please. So we'll jump to doing the performance and load testing with the JMeter. And yeah, so it's an open source tool built by Apache Foundation and primarily for performance testing. So we will take a short break, and meanwhile I also ask you to please download the JMeter if you have not downloaded it. So please download the JMeter, and then after the break we will also start doing the more hands-on as to how do we go about doing the performance testing. Please download the JMeter, depending, choose this the systems that you have or the machines that you have. The one that I am using is, I think, JMeter 3.1. And you can choose the version that you are interested in. The one that I am using is 5.6.3. I don't think there are many new releases after that. You can check, please do check. Please put it on download, and also let's take 10 minutes break, and on the other side we will get